Alright, so as promised, here is the video for the second part of your lecture, and it's going to continue to deal with quadratic functions. And this time we're going to go ahead and take a graph and write the equation in vertex form. Okay, now y'all remember that to write an equation in vertex form, we have it y equals 2a times x minus h squared plus k, right? Where obviously h and k are your vertex. And A is just that number that tells us whether it opens downward or upwards, and whether there's a stretch or a shrink, right? So here we have that A is going to be less than 0, and we know this because our parabola is actually facing downward. Okay, so we need to go ahead and figure out what H, K, and A are. Okay, now it's very simple to see the vertex on this particular graph. Okay, the vertex is going to be of the ordered pair negative 9, 1, negative 1. Okay, so we can automatically substitute that into the equation in vertex form, right? So now we have y equals to a times x. Now, since h is negative, right, that's just the x coordinate of the vertex, we have 8x plus 9 squared and then minus 1. Okay, so that's the first part. Very simple. Second part, we need to go ahead and figure out what a is. In order to do that, we're going to go ahead and take a second point on the quadratic equation, on the quadratic function, and we'll just substitute it to x and y into the formula itself. Okay, so this particular ordered pair has the coordinates negative 12, negative 7. Okay, obviously this is your x coordinate, this is your y coordinate, and we'll substitute them accordingly into the equation. So y is negative 7 equal to a, which is what we'll be solving for, times negative 12 plus 9 squared minus 1. Okay, and then it's just simple arithmetic and solving. So you have negative 7 equal to a, negative 12 plus 9 is negative 3 squared minus 1. Okay, negative 7 is equal to a times 9 minus 1. Okay, you're just solving for a now, right? So we add 1 to both sides. These cancel out. Oh, I'm sorry, that doesn't cancel out. My bad. I'll write it over here. This gives you negative 6 is equal to 9a. Divide both sides by 9. We get that a is equal to negative 6 over 9, which we can reduce to be negative over 2/3. Right? So that means our equation in vertex form of the parabola that's given is y equals to a, which we know is negative 2/3. So we have negative 2/3. Okay, x plus 9 squared minus 1. Okay, and that's your equation in standard form. So let's look at another example, the second example that you have here. Okay, again, you want to make sure you have the vertex of your parabola. In this particular case, the vertex is going to be negative 4. I'm sorry, not negative 4. It's going to be 4, 7, negative 7. Okay, and then the second ordered pair is going to be 6, 7. Okay. All right. So again, you have the equation in vertex form, y equals to a times x minus h squared plus k. Now, we just substitute h and k, which are given here by the vertex, right? hk. And we have y is equal to a times x minus 4 squared minus 7, right? Because k is negative, so that plus minus becomes minus. Okay, now we just need to figure out what a is. In order to do that, we'll go ahead and substitute the ordered pair 6, 7 again. Again, this is going to be the ordered pair xy. So we just substitute y for 7, so we get that 7 is equal to a times x minus, what was it? Oh, x minus 4 squared minus 7. Okay, and then, oh wait, I'm sorry. X is supposed to be 6. All right, anyway, so you have 7 is equal to a times 2 squared minus 7. So we have 7 is equal to 4a, right, minus 7. Add 7 to both sides. These cancel out over here. We end up with 14 is equal to 4a. Divide both sides by 4. Okay, we end up getting that a is equal to 7 over 2, or 3.5. we'll just leave it as an improper fraction. So we have that y is equal to 7 over 2 times x minus 4 squared minus 7. And that's the equation to the second example. All right, let's go ahead and really quickly look at a word problem. I know I'm kind of going kind of fast, but of course y'all can just rewind it or do whatever you want to go over the examples again, or you can ask me later on today. All right, so in this example, we're going to go ahead and kind of apply what we did yesterday and do a word problem. You do have a word problem very similar to this on your homework, and you will have a problem very similar to this on your exam. So make sure you know exactly what you have to do. Okay, so in this particular problem, we have that Bob. See, Bob, I told you, I talked to you. Okay, Bob is going to divide up his land into some grazing area. God, I always misspell everything, huh? Area for his cattle according to the diagram below. He has 2,000 yards of fencing to divide his land. So from this word problem, I know that we're going to go ahead and fence in everything that I'm about to highlight in green. Okay, so the fencing is going to be this, right? And we know that Bob has 2,000 feet of fencing. Okay. All right. So we did a problem exactly like this before. Okay. And I don't know if you remember, but we did do a problem exactly like this. Now we know that we have 5 identical pieces, and we're going to go ahead and label them X, right? Each one of these pieces is X yards long, right, or wide. All right, and we also have this vertical length, which we'll go ahead and label as y. Okay, now we know that if we add up all of these green pieces, we'll end up with 2,000 yards. So essentially what we have is y plus, and there's 5 x's, right? Y plus 5x is equal to 2,000, right? So in fact, that's actually the answer to part A. Write a function for the vertical length of this diagram in terms of x, the horizontal length. So we're going to go ahead and call this, let's call it Vx, right? Because it's the vertical length. This is going to be Vx, and what we're basically doing in this equation is solving for y. Okay, so we know we need to subtract 5x from both sides. Okay, these cancel out, and we end up with y is equal to 2,000 minus 5x. Okay, so our function for the vertical length of this diagram, which is this part over here, in terms of x, is going to equal to 2,000 minus 5x. Okay, now we want to go ahead and write a function for the area that can be enclosed by this fencing. All right, now we already know that for area, especially of a rectangle, the area of a rectangle is just going to be length times width. Now, the length can be given by the function we found in part A, right? And the width is, of course, x. So if we want to go ahead and find a function for the area, it's going to be a function of our width, and that's going to equal to the length, which is going to be 2,000 minus 5x times the width, which is x. And of course, we can go ahead and distribute this particular term, this particular factor, and this becomes 2,000 x minus 5x squared. So that's our quadratic formula for the area that is enclosed by the fencing. Okay. Now the next part is to go ahead and state the domain and the range. And we already know that this particular equation, the one in B, is written in standard form, right? And in standard form, we really don't get much information other than the y-intercept and which way it opens up, right? This particular equation, we can see that the y-intercept is equal to 0, and that it's gonna, since A is less than 0, right, A is at -5 right here, we know that it's a parabola opening downwards, which means it has a relative maximum, right? So that's all we know, okay? But we can't really look at the equation and figure out from where to where we will have a domain or from where to where we will have a range. Okay, in fact, what we're gonna do is we're going to go ahead and transform this into an equation in vertex form, which is what we did yesterday. All right, so we're going to go ahead and take a of x, and I'm going to remove it a little bit. I'm going to write it as -5x squared plus 2,000, right? Now x, right, 2,000x. Now, when we did this yesterday, we did a process called completing the square. And in order for us to be able to complete the square, we know that the leading coefficient, in other words, the coefficient of x squared, has to be 1. So the first step is going to be to factor out, okay, that -5. So we go ahead and take out that -5, and we're left with x squared minus 400, right, x. Okay. Now, I know that when I complete the square, what I'm going to have to go ahead and do, okay, what I'm going to have to go ahead and do is add a number here, right? -5 times x squared minus 400x, and I'm going to go ahead and add a number, right? We're going to go ahead and add a number. Okay, now, remember, since we're doing this to the same side, I have to really add 0. So I need to also subtract that same number, okay, whatever it is I added here, okay? Now, in order to figure out what that number is, remember that we just take b, which is -400, divided by 2, and you square it, right? So b divided by 2, and then square it, which actually gives us the number, okay, 40,000, right? 40,000. Okay, so then we don't really add 40,000 to this area right here because we know that this 40,000 is being multiplied by this -5. So the number we're going to have to subtract is -5 times that 40,000. Okay, now we know that the negative coming from this 5 and the minus that's here, okay, once we put them together, it's going to give us a positive, so we're really going to add here. Okay, and we're going to go ahead and add 5 times 40,000 is 200,000. Okay. All right. So now after we've done this completing the square process, we can go ahead and factor out the trinomial that we have, that x squared minus 400x plus 40,000. So we have -5 times x, right? And we know we're going to have two identical terms, and I'm just going to put plus 20,000 or 200,000. Okay, so I know I'm going to have two identical factors, x, right? Now, this sign tells me that they're both the same sign. This sign tells me what that sign is. So we have minus, minus. Okay, and remember that b will always tell us, or what we have in this parentheses, right? B divided by 2 will always give us what we're going to go ahead and have as that second term. And we had that 400 divided by 2, -400 divided by 2 gave us that -200, which is where the minus comes from, essentially. So minus 200, okay? Which we can finally write as -5 times x minus 200 squared, because we have two identical terms, plus 200,000. Okay, and that's the equation in vertex form. All right, now, the purpose of this was to go ahead and state what the domain and the range were, correct? So what we're going to go ahead and do is kind of picture what exactly is going on. Okay, so here's my quadratic, and I'm only going to go ahead and do the first quadrant because we already know we're working with area and length, and area nor length can be negative. So from part B, right, when we wrote our equation, we clearly stated that the y-intercept is going to be 0, right? 0, 0. So I know that my particular parabola goes through this point. I don't want it to go down here, right, into quadrant 3, because we know that we can't have negative area and negative width. So we don't need it to go that far. We can actually start it at 0, 0. Okay? Because A is negative, we know it opens up downward. So it looks something like this, right? And it keeps going down. Now, I don't need it to go any further than this point. Okay, again, we cannot have negative area, and if we go down into quadrant 4, we're saying that area is negative. Okay, so really this is the quadratic that we're looking at. Okay, and we now know what this point is without graphing on the calculator. We know, because of this equation, that we're working with the vertex of 200, right? So that's a width of 200 and an area of 200,000. Okay. Now, we're asked for the domain and the range. okay? The domain, we'll go ahead and start with the range actually. The range starts at 0, right? And it goes all the way up to, okay, our y coordinate, which is going to be 200,000. So I'm going to go ahead and write the domain off over, where can I write it? Okay, over here. So we have that, well, that's domain, the range. Okay, the range in interval notation is going to go ahead and start at 0. Now it can't be 0, right? We can't have an area of 0. But we're going to go all the way up to 200,000. And 200,000 is included in our range. Okay? Now for the domain, okay, we're going to go ahead and not, like, we don't need to find the other 0 in this particular case. It's way simpler than that. I already know that this graph is symmetrical, and I know this number right here is 200. So if I know the distance from one 0 to the other is 200, okay, I know the distance from the center, oops, not from one 0 to another, right, I'm sorry, from one 0 to the axis of symmetry is 200, then I know from the axis of symmetry to the other 0, we have to go ahead and go another distance of 200. So this x coordinate over here, this 0 over here, is actually 400, right? So the domain then can be stated as going from 0 to 400. Okay, none of those points are included just because it wouldn't make sense in the context of the situation. Okay, so we've stated our domain and our range, and all without using the calculator. Okay, now looking at part D, if the horizontal distance between the river and the far left of the diagram is 15 yards, what is the area enclosed? So in other words, okay, if this particular length is 15, what is the area? So now we're looking for A of 15, right? So all we have to do is substitute 15 for x in any equation that we have for area, and that'll work. So we're going to go ahead and use the one for the standard form, the one we originally had, which was -5, right, times x, which is now 15 squared, plus 200, or 2,000, I'm sorry, times 15. And if you plug that into the calculator, it'll go ahead and give you the answer of 28,875 square yards. Okay, that's the area. Part E says if the vertical distance from the top horizontal fencing part to the bottom horizontal fencing part is 600 yards, what is the area enclosed? So in this case, we're saying if this entire length is going to end up being 600, right, what is the area? Now, we already had an equation for that. In fact, it was given in part A, right? So I know I can set this equal to 600. So 600 is equal to 2,000 minus 5x, because I need to figure out what x is in order to be able to use my area formula since it's dependent on x. All right, and if we go ahead and solve this, we get that x is equal to 280. All right, all we had to do was subtract 2,000 from both sides, divide by -5, and we get that x is equal to 280. So now we have A of 280, okay? And again, just like in part D, we're just going to substitute x with 280 in any one of these equations. So we have -5 times 280 squared plus 2,000 times 280. Okay, and if we go ahead and plug that into the calculator, you get 168,000 yards, square yards, right? Because this is area. Okay. Last part. What are the dimensions the farmer should use so that he encloses the most area? Wow, second mistake. Okay, the most area. Okay, so we already know the most area will be given by our maximum, right? We have a relative maximum in this particular graph. All right, so I know that I'm going to be using the vertex. Okay, the vertex was, of course, 200 and then 200,000. Okay. All right, so this is my x coordinate, right? And I want the dimensions. So I don't want just the width, which is what I have. I also want the length. So in order to do that, we're going to go ahead and use the function we have in part A, v of x. So I know v of 200 is going to go ahead and equal to 2,000 minus 5 times 200. Okay, so this v of x is going to end up equaling to 1,000. Okay, and y'all can do that simple math. All right, so I know if I want, or if the farmer, which in this case is going to be Bob, if Bob wants to enclose the most area, the dimensions of his particular, what is it, grazing area, okay, should have a width of 200 yards, right? That's coming from this particular x coordinate, all right, and a length of 1,000 yards. Okay, which is coming from what we got when we substituted x into that first function. Okay, so that is it for this particular lesson. It's very short. You have a word problem to work with. You have 2 examples for the Pictionary problem, so you should be able to finish your homework. The homework is due on Thursday, so make sure that you review the notes, and if you need any help, go ahead and come by during Power Hour.